Today's daily dose of math has to do with a statistics problem. We have two classes of students, Doug's class and Eli's class. And the students in these two classes have been asked to try using a new workbook that has been found. It's on the topic that they're studying, but it's from a different curriculum. The teachers aren't sure if the workbook is going to really be useful. So what we're doing is we're asking 10 students from each of the two classes to record how many hours they spend using the workbook. And we're also providing the grades that these students got in the math course that they're studying. I'm going to use this data for more than one question though. So if you feel like you've already seen this video, maybe you haven't. I intend to use these two sets of data for 3 different videos in which the students are learning 3 different techniques for how you deal with some statistical data. This time though, what the students are being asked to do is answer this question. Which class benefited more from the workbook? Now, the students can find a correlation equation with data like this, but a correlation equation isn't really useful when you're answering a question like this. It's not asking the sort of question where it gives you a value and asks you to plug it into an equation to find an answer value. No. And this sort of data can also be used to find mean deviation. Mean deviation is a very useful statistical tool that can be used to compare data. But this type of question doesn't really put us in a position where mean deviation is useful. So a student who knows what they're doing in this course looks at a question like this and realizes, I need to find the R value. I need to find the correlation coefficient. Because if I can show that there's a relationship between the number of hours studying the workbook and how high your grade is, then that is a correlation situation. So that's what we're going to do here. Now, the first thing a student should do in this situation with this type of question is draw the scatter plot for both, because that is a way of analyzing the situation. And in fact, before you find your correlation equations, looking at the scatter plot can give you quite an idea of what you have. And right away, I'm already, as a student, I'm already ready to give a partial answer to this question once I see my scatter plots, because I can see that there is a hint of a positive slope here. And that means the more hours you use the workbook, the higher your grade is going to be. Whereas here, I'm seeing a negative slope. And what that means is the more hours you spend on the workbook, the lower your grade is going to be. So already I start to have an opinion that Doug's class looks like they benefited from using the workbook because they have a positive R value. And Eli's class looked like they did not benefit at all. But I want to prove it, and so the next thing I'm going to do is I'm going to use whichever method I want, either the box method or the calculator, to find the correlation coefficient for each set of data. And I've done this here. In Doug's class, the correlation coefficient is 0.8, and it is positive. That is a moderate, positive moderate correlation. And I give my line from the table where I judge the correlation. 0.8, the absolute value of 0.8 is in between 0.75 and 0.85. That is why I'm saying it's moderate. In Eli's class, although we have a negative R value, it's negative 0.66. And that falls, the absolute value of negative 0.66 falls between 0.5 and 0.75. So therefore, this is a weak correlation. But importantly, it is a weak negative correlation. Now remember, if you're studying statistics from a different curriculum than the one where I'm teaching, you may be using a different table. So in the table that the students have to use for the courses that I teach, this R of 0.8 is moderate, and this R of negative 0.66 is weak. If you're learning your statistics in a different curriculum, it's possible you're using a different table, and you would be judging this differently. Be careful of that. But now I have enough information so that I can give my final answer to the question. And the final answer is a little different this time, because very often when you're comparing correlation coefficients, you're really just looking for which one is better. And moderate is better than weak. It means that there is more justification to say there's a connection between these two things. In this case, the connection between number of hours on workbook and grade. But the answer here is actually simpler, because what I'm going to say as my final answer is Doug's class benefited more, and the reason is because the R value, the correlation coefficient, was positive. Mentioning that it's moderate and that is considered more of a correlation than weak can be said, but it's not really necessary, because the fact that there's a negative correlation in Eli's class means that students who spent time on the workbook actually got a lower grade in the course, so they didn't benefit at all. And I've covered that with this answer. This type of question is a task. It's one of the larger questions in the exams that I'm preparing students for. And in that type of task question, this is a common situation in that the question isn't telling you what techniques to use. It's not telling you that you need to compare correlation coefficients. The student is expected to figure that out themselves. Another thing to note is that I did not show the steps of using the calculator to find the R value because I have another video that shows that. And I did not show the steps of using the box method to find the R value because I have another video that shows that. I didn't want this video to be too long, and it takes quite a bit of time for a student to draw a scatter plot and then use whichever method they want to find the R value. And that is part of the reason why this would be considered a task type of question, because it takes more time to answer. That is today's Daily Dose of Math. Please like, subscribe, and share.